Today's topic is probability. The quality or state of being probable, the extent to which something is likely to happen. A probability is a number that reflects the chance or likelihood that a particular event will occur. Probabilities can be expressed as proportion that range from 0 to 1. The numerical measure of uncertainty of an action called probability. Let x be any event, then its range, that is 0 to 1. That we can say Px is either greater or equal to 0 or less than equal to 1. It means every time the probability answer we get between 0 and 1. The next term is random experiment. If an experiment, when repeated under identical conditions, do not produce the same outcome every time, but the outcome is a trial is one of the several possible outcomes, then such experiment is known as random experiment. For example, tossing a coin twice may be a tossing a coin thrice, or tossing a coin 4 times. Rolling an unbiased die and drawing a card from a well shuffled pack of playing cards. The next, that is deterministic experiment. In our day-to-day life, we perform many activities or experiments which have a fixed outcomes or result no matter any number of times they are repeated. Such experiments are known as deterministic experiment. For example, set of all triangles in a plane. If a triangle is chosen, then even knowing the 3 angles, their sum is always 180 degree. It means the sum of interior angles of a triangle is 180 degree. Second example, experiments in science and engineering are repeated under identical conditions. We get the same result every time. Sample space is the next one. The set of all possible outcomes of a random experiment is called sample space. It is denoted by S. Each element of a sample space is called a sample point. For example, we toss a coin twice, then total outcomes will be head head, head tail, tail head, and tail tail. And another example we can take, if you toss a die or throw a die, the outcomes are 1, 2, 3, 4, 5 or 6. So these are the total outcomes which are the result if we toss a die. Second one is equally likely event. Each outcome of an experiment occurs with equal probability is called equally likely event. For example, if you toss a fair coin, a head and tail are equally likely to come. If you toss or throw a die, the equally likely event will be 1, 2, 3, 4, 5 or 6. Any number can be comes up. The next one is now mutually exclusive event. The two events A and B are called mutually exclusive event if the occurrence of any one of them event, the occurrence of the other event, if they cannot occur simultaneously, then the set A and B are disjoint. Mutually exclusive event means if the two events do not have any common element or any common number, they are mutually exclusive event. For example, consider a die. The total outcomes are 1, 2, 3, 4, 5 or 6. Let A be the event getting even number, that is 2, 4 and 6. Let B be the another event getting odd number, that is 1, 3 and 5. And C another event getting a multiple of 6, that is 3 and 6. So these are the outcomes we have taken if a die is thrown. Again repeating, let A be the event even number, that is 2, 4, 6. B be the event getting odd number, that is 1, 3, 5, and C be the another event which is a multiple of 6. So the numbers are 3, 6. Therefore, A and B are mutually exclusive event because there is no number which is common to both A and B event. C and B, A and C and B and C are not mutually exclusive. B and C are not mutually exclusive because 3 is the common number which is present in both, and A and C, there is 6 is the number which is common to both. Therefore, A and C are not mutually exclusive event. Exhaustive events. 2 or more events associated with the random experiments are exhaustive if their union is the sample space. So suppose there are the 2 or 3 events, their union is equal to the total outcomes, then it is called exhaustive event. So here you can say the A1 union A2 union A3 dot dot union of the n terms of that event is equal to the total outcomes, or you can say the total sample point, then it is called exhaustive event. I hope children you are getting this point. If 3 coins are tossed, we can better explain this using these examples. If 3 coins are tossed, the total outcomes are head, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, T, comma, T, T, T. Consider the events. Let A be the event. At most one head. At most means maximum one head, or there is no head. So the points are HTT, THT, TTH and triple T. B be the event, exactly 2 head. Exactly 2 head. That is HHT, HTH and THH. C be the another event having exactly 3 heads. So that is triple H. So A union B union C. If you take the union of all these 3 events, that is A, B and C, that is equal to the total outcomes when a coin tossed 3 times. So A union B union C is equal to S, total outcomes. These events are mutually exclusive and exhaustive. It means no trial is common, no event is common there. In A, B and C they are mutually exclusive event, but the union of all these is equal to the total outcomes. That's why it is exhaustive event. I hope you understand this. Okay, student, taking these 2 questions in support of the topic what we taught. The question number 1 is, 2 dice are thrown and the sum of the numbers which come up on the dice is noted down. 2 dice are thrown and some of the numbers which come up on the dice is noted. I hope you know that if you toss pair of dice, the total outcomes we get 36. So here let A be the event, the sum is even, that is you write the total actually ordered pair 1 1 1 3, 1 1 total is 2, 1 3 sum is 4 which is even number, 1 5 sum is that is 6 which is even number. Similarly 2 2, 2 4, 2 6, 3 1, 3 3, 3 5, 4 2, 4 4, 4 6, 5 1, 5 3, 5 5, 6 2, 6 4 and 6 6. So sum of all these ordered pair is the even number. B be the another event where the sum is a multiple of 3. Multiple of 3, that is 3, 6, 9, 12, 15 and so on. So the first ordered pair is 1, 2, 2, 1 the second ordered pair, then 1, 5, 5, 1, 3, 3, 2, 4, 4, 2, 3, 6, 6, 3, 4, 5, 5, 4 and 6, 6. The sum of all these ordered pair is a multiple of 3. See the another event where the sum is less than 4. It means sum of the ordered pair is less than 4. 1 1, that sum is 2 which is less than 4. 1 plus 2 is 3 which is less than 4. 2 plus 1 3 which is less than 4. And D with the event where the sum is greater than 11. So if you toss a pair of dice, the maximum, the 2 number whose sum is 12, that is 6 6. At 6 6 sum is 12 which is greater than 11. So now get the A intersection B. How many ordered pair are common in A and B? So we find out that 1 5, 2 4, 3 3, 4 2, 5 1 and 6 6. So these are the common ordered pair in event A and event B. A and B are not mutually exclusive event. Again, children, try to understand this point, that mutually exclusive means the two events where there is no element is common, no number is common, that is mutually exclusive. They are separately. They are existing separately. So check this again now. A, we have written this sum is even number, and B with the event where the ordered pair sum is multiple of 3. So they are mutually exclusive event. C and D are mutually exclusive event. C and D are also mutually exclusive. C, we have taken the sum is less than 4, and D where the sum is greater than 11. So no ordered pair is common in C and D. That's why the C and D are mutually exclusive event. So children, I hope you understand all about the sample space. That sample space means the total outcomes of a random experiment is called the sample space. Equally likely means when the outcomes are supposed to become in equal proportion, any numbers can become up. If you toss a die, you can get head, or maybe you can get tail. Or sorry, if you toss a coin, you can get head or tail. If you toss a die, you maybe get 1, 2, 3, 4, 5 or 6. Any number can become up. That's why these are the best example of equally likely event. I hope you understand this. Exhaustive means that union of total event is equal to the sample points or total outcomes. Thank you so much.